Start, sir.
Hello friends, and welcome to this third live session for the course Water Supply Engineering. So practically this is our kind of last interaction for this course. Of course, if you have any further queries or if you want more discussion, there is forum where we can have further. So where we can have further interactions. Okay. So in this live session, we are going to take questions. So whatever questions you have, you may post it in the chat box. We'll be picking up your questions from there, and we'll be kind of happy to answer those questions. To begin with, let's start with some of the questions which has been received in the Google form, okay, for this particular live session. So there is a question on what is the max hour of stability for water supply network. So actually, if I understand this question correctly, you want to know that what is the max hour of operations for stability of water supply network. So if that is the point, then the operation of network means under a different component of networks depend on their capacity. So as a whole, we can fairly run the water supply system round the clock. 24/7 supply system, when we talk about the 24/7 supply system, those systems work for kind of round the clock, okay, continuously throughout the year, 24 hours a day, without any problem. So the water supply network can operate 24 hours there, okay, but yes, there are various components which need some sort of cooling off period in between, like for example pump. So you cannot run one single pump 24 hours round, means one single pump round the clock for years, okay, that will fail. So that's why when you are, let's say you are setting a pumping station, so you need to kind of understand that what are the pumping hours, which typically can be kept any depending on the flow. If large flow is needed, you can run your pumping station also 24 hours. If smaller flow is needed, you can run it just for let's say 8 hours, 10 hours, 12 hours, 16 hours, 18 hours. So there are different time people operate these pumping stations. However, operating a pumping station does not mean that a pump will run for that long. Okay, if we are operating a pumping station 18 hours or say 24 hours, that does not mean a particular pump is going to run 24 hours. What it means that we will have adequate number of pumps installed so that if our requirement is to run 4 pumps at a time, so we will run 4 pumps at a time. Then maybe we have say 10 pumps installed or 8 pumps installed. Generally, like twice the number of pumps are installed than that is required actually. So if we require say 4 pumps, we'll install 8 pumps. So we will run these 8 pumps in the batches. Okay, we are running first 4, then letting them cool off, running other 4, then running other 4. Or let's say it's not necessarily that we operate in a batch of like exactly that way. Let's say we start one pump at 1 o'clock, second pump at 3 o'clock, third pump at 5 o'clock. So by the time like at a time set of 4 pumps will be running. Okay, so that sort of thing can this way it can be managed. So these electrical systems and these systems which need some cooling off period are basically provided in addition, like mixing tank. If you want to use aerators in a basin, so again you can have some cooling off period for aerators as well, install some more. Okay, you may run a tank at a time, and then other tank you can keep on a standby. So there are variety of these kind of variety of components of a water supply system may be operated for different times. Okay, but overall a water supply network can operate for 24 hours easily provided all the adequate systems and those things are there. There are like a few things which can, like it's a, let's say, pipe. Okay, there is a pipe flow. So pipe, it doesn't, you don't need a cooling off period for pipe. Let the water flow through the pipe round the clock, 24 hours. Okay, there is absolutely no problem with that. Generally, these mechanical or electromechanical systems, they need some buffer period, okay, a cooling off period. So we provide them in addition, or we provide these kind of mechanical stuff in the standby. But otherwise, majority of the component can run 24 hours, and absolutely there is no problem related to that. Okay. So this was the one question which was posted by Petro. There is a question by Subham. Okay, so Subham is working on an interesting concept. I think we had had a brief interaction earlier in the first live session as well. So Subham is asking that he is developing a water quality index using artificial neural network, and then he needs help in deciding weightage allocation in development of indices, and what is the scope for further development in this field using machine learning and artificial intelligence. Okay, so Subham, actually, when you see ANN or like any other machine learning tool or artificial intelligence systems, they just facilitate analyzing the data in a desired way, okay, to yield certain correlations and those kind of stuff. Wherever, particularly with when you are developing an index, let's say water quality index kind of thing. So there are in fact quite some work has been done in this field already. But when you come on to assigning weightage to the different parameters out there, okay, so when you are working, like your primary question, as I understand, is you want to know that how we should decide the weightage for different parameters in developing of a water quality index. So there is, let's say, a set of water quality parameter. There is pH, salinity, turbidity, and then of course there are various other metals, TDS, conductivity. So a variety of parameters are there. Now, assigning weightages means giving the relative importance to these parameters. Okay. Now, there are statistical approach to assign weightages, but none of them are foolproof. Okay. There is in fact a book on assigning weightages, and I will share the reference of that book with you probably, okay, sometime, where you can see that what are the different methods people adopt for assigning weightages. Okay, but again, for most cases or the most work which has been done in these domains, these weightages are still subjective. Okay, your ANN or machine learning tools can help once you can help in analyzing data. Of course, you can because see, if you have a pool of data, you can analyze it a number way, and that will result in some number as well. So even if you want to analyze or say assign a weightage based on this, weightage assigning for water quality parameters means actually you are assigning a scale of importance. So that means you are saying that this particular parameter is more important as opposed to this particular parameter or this parameter or this parameter. If you really want to employ the artificial neural network or machine learning in a very effective way for these kind of analysis, you will have to have a vast set of data that what is the individual or specific impact of these parameters on your designated use. Okay, so if your water quality parameter is targeted for drinking purpose, then what is the impact of these? So if you have a vast pool of data, then you can kind of analyze the sensitivity of each and every parameter. Okay, you need to analyze sensitivity of each and every parameter, and then accordingly which one is the more sensitive. for health impact or whatsoever final impact, you can assign higher weightage. So if you get a sensitivity of all these parameters, you can assign a relative weightage based on the sensitivity values. However, again, as I said, that it's a very, very challenging thing because that kind of data is not there. Means you cannot get adequate kind of data where basically you have a pool of for a pool of water quality parameters, what are the specific impacts when all other parameters are remain same. Okay, so that is probably going to be the most scientific way to analyze weightage if we can get that sort of data. In absence of that, which generally what people follow, they go to the some sort of quantitative assessment is difficult, so they go to some sort of qualitative assessment. Okay, they will kind of see that or take the opinions or see, okay, let's say TDS is very important or those sort. There is some normalization, statistical normalization techniques, all that. So that also can help. Okay, so Subham in between is saying that currently I have data of 3 years with over 3,200 entries. Okay, these I think we need means you need to kind of explore. I just by reading your line, I cannot perceive that data of 3 years, but data of what? Okay, 3,200 entries of what? Are these 3,200 entries belong to the different parameters and associated impact? Okay, so if it's the case, then you can opt for these sort of sensitivity of each parameter and assign a weightage accordingly. That would be the ideal. Okay, I asked you over mail, but don't know you received. Okay, I think I did not see your mail, or I might have missed that. I will recheck if it is there, or you can send me a mail, another mail. I will. I'll be happy to. Yeah, if you can share your data and over email, what kind of data, then we can have a discussion over this. That like you have 14 parameters, but 14 parameters means you have value of those parameters or value associated with the impact for, because when you are saying water quality index, first thing you have to make sure that index, water quality index would be different for different applications. Irrigation water quality index is different. Drinking water quality index is different. So bathing water quality index might be different. So you can have a different water quality index for different applications. Okay, so if you are willing to develop a water quality index for drinking purpose, we just don't need the value of these parameters. We need the associated impacts. Okay, because having the value of these parameters is still like you can not only 3,200, you can have 32,000 numbers, but that doesn't give you any information about what impact they are going to create, based on which you can assign a relative weightage or importance of these parameters. Okay, so just value of these parameters will never be able to guide you. Like I have a pH, I have say 10 samples and I monitor 10 different pH, but until unless I know that what are the impact of these pH values, these different pH values, how I'm going to assign a weightage that, okay, this pH is adequate, or this is the impact, or this is the weightage for related to pH. In any case, yes, there are methods, and as I told you that I will share you the reference which you can explore for this, for assigning in indices, okay, or assigning. There is some standard methods for assigning weightages also, but in particularly like in case of these kind of situations where you have to develop a qualitative index, you still, like, these methods are not very foolproof, and you will still have to either rely on the qualitative assessment by the experts, by the peer, by the people, or you have to have the robust set of data which can guide you like that. So this is a in quite interesting work, and I'm sorry if I have missed your email earlier. I'll be if you can send me another mail, I'll definitely be like I'll definitely reply you, and we'll share you some reference material as well. Okay. So I'm. You want my email? It is already there, but I'll just write in any case. Okay, I may have missed your mail. I'm not saying that like it may have come, but because last month I was traveling a lot, so I may have missed your mail. Anyway, so I think it's time we move to the next question, and we can have further discussion for sure on this. Okay. Um, all right. Next question is by Sachin. Okay. So Sachin has asked that is it safe for long time our health if we drink alkaline water like pH 8.5 to 9.5 and alkaline minerals, negative oxidation reduction potential compared to potable waters of pH around 7. Okay. So I understand that there is a lot of debate going on this aspect. Okay, the particularly like use of alkaline water. So many people are promoting the alkaline water. There are few companies also which are promoting alkaline water, and of course they are claiming lot many health benefits of alkaline water. Having said that, uh, it's it's not yet scientifically proved that it is going to make any significant advantage or significant benefit. Okay, so alkaline water, there are like based on of course based on their oxidation reduction potential or the production of antioxidant and those things which are being promoted. So people do use that also, and there are positive report, but I particularly means have not investigated it whether it is like many of such things get stage managed. Okay, so all these like the talk about alkaline water is generally promotion by the companies who basically sell alkaline water. On the scientific front, there are not adequate resources, or there has not been kind of there has not been adequate justification provided that alkaline water could benefit the health as opposed to using the normal potable water. Okay, so uh, that is about alkaline water. Okay, so alkaline water, maybe I'm not saying that it is means it is for as far as safety is considered. Yes, people are using it and it is safe. It's not like there is negative health effects have also not been reported much about this. Okay, so it may be safe. Okay, but until unless there is of course long term studies to justify that what kind of net health impact it is going to produce as opposed to the like normal pH range for potable water, which is again up to from around 6.5 to 8. So 6.5 to 8 is common, but alkaline water is generally have pH values higher than 8. So of course there needs to be like comprehensive and long-term studies to come to any solid conclusion for this. Okay. All right, there is another question on by Manu. So the question is, what kind of advanced treatment options are cost effective for removal of emerging pollutants? Okay. So there are variety of options available for the advanced treatment. Okay, advanced treatment means is anything that we provide beyond the conventional stage of the filtration and disinfection. So as we discussed during the lectures as well, till the the filtration process, we generally remove the suspended and collided materials, and then we, through disinfection, we try to we try to reduce or eliminate the effect of microbial impurities or pathogens. But we do not, conventional systems are not aimed at treating these emerging contaminants, which includes pesticides, personal care products, pharmaceuticals, okay, and various other some industrial chemicals, and those kind of things are there. Okay, now for these we go for advanced treatment options. Okay, and as discussed, there are nowadays the popular advanced treatment options comes in the form of like membrane systems. So you have the ultrafiltration, nanofiltration, or reverse osmosis. Okay, and the so that is the most effective. Okay, if we are talking about in terms of the efficiency, so the RO systems or these high-end membrane process like RO or these systems are most effective for removal of any sort of pollutant, including the emerging contaminants. Okay. However, as your question is that what are the cost-effective options? So in the cost-effective options, we will like if you see the as opposed to the membrane filtration system, the cost of one of the other popular systems are the adsorption processes, which works on the particularly like activated carbon adsorption process, and these. So they are they will have almost 1/3, means roughly, it's not exact number, but roughly 1/3 cost of the 1/3 cost of the means when we compare with the cost of the membrane processes, we'll typically have 1/3 cost, particularly like with the high-end RO systems and those things of activated carbon filters or those kind of systems. The efficiency is less. Okay, of course, means activated carbon unit will never give you the efficiency of that of RO system. But having said that, in most cases, if your water is not too polluted, or it is not kind of coming from a waste stream or mingling with a waste stream or that sort of, for majority of the natural waters, the emerging contaminants, particularly the emerging contaminants of organic nature, can be kind of removed using activated carbon systems as well, if not all, significant amount of. So if your water is too heavy contaminated, and these carbon filters or activated carbon filters are not good enough or sufficient enough to kind of eliminate those, then we might have no option but to go to the high-end RO system, which is effective but costly. But if it is not, means like our normal water, river water, or many times the groundwater or those things, so if there is one or two of those sort of contaminants present also, the concentration will not be that high, and these activated carbon filters and these also can eliminate or can retain these sort of emerging contaminants, particularly the organic emerging contaminants. Okay, so they can be used that way. Okay, and they are much less costly than the membrane filters. There are other options also. Then of course there are various natural adsorbents are being studied. People are being investigated various other natural adsorbents or other kind of systems as well. So these natural adsorbents or the photochemical degradation, okay, the advanced oxidation processes, low cost advanced oxidation processes, where basically we try to generate the hydroxyl radicals using low cost systems. So those systems are also being investigated and have shown a variable degree of success as well. Okay, in the field, it's not only, I'm not talking about success in the lab or research papers, they have shown the success in the field as well. But again, depending on the raw water quality, raw water composition, if you want to choose a most suitable or most efficient or most cost effective system, you'll have to first investigate what are the raw water characteristics, and based on that raw water characteristic, what are the available systems which can remove that. So as I told you that, let's say for emerging contaminants, for very high concentrations, you will probably have to go for RO. For low concentrations, even your activated filter or some sort of other low cost oxidative removal. Okay, so they also can take care of these issues. So I think that is the way you enlist, you identify all the possible treatment options, okay, and then you see which one is going to be the most cost effective. Generally, among the advanced treatment systems, the RO systems is the most costly, then the lesser cost will be as you come down, like nanofiltration, ultrafiltration, microfiltration, the cost will be keep on going down. The activated carbon is further lower. Ion exchange will have little higher cost than the activated carbon. Okay, but that is good for removal of ionic impurities only. Okay. So you can that way sort of list these processes. There are some chemical, as discussed in the lecture classes as well. Okay, so we have some chemical methods as well. So they also have various degree of success. Cost wise, they are low, but then success rate also is accordingly. Okay. For few, means not emerging contaminants, but like again, let's say for fluoride, arsenic, those kind of contaminants also. So you have a low end chemical methods, then high end systems are also there. So you can cut down on the cost or cut down on the energy use, but simultaneously the efficiency will also be keep coming down. So you can then make a decision. You can then make a decision that what is my requirement and at what minimum cost, because you can list the different process and then you can list the sort of likely removal efficiencies, and based on that you can see that what is the best cost effective solution for your case. Okay. So there is another question again by Manu, is what is the best model to price water? Is cost of metering all consumers justified? That's another kind of issue of debate. Okay, there are the concept of universal metering, where we meter all consumers. Okay, has to be evaluated again based on the return on investment. Okay, so if we are investing by metering all consumers, are we able to, what are we able to get in the return? One thing that we'll be getting is the end user data, and that's a very valuable asset. Okay, we are going to get the end user data, that's a very valuable asset. But
Sir, sorry to interrupt you.
Yes.
There is some network issue in your end.
Is it not connected? Hello? Am I audible? Am I audible? Hello? Hello? Okay, looks like some network issue. Okay, I think it's I'm audible, so I will continue then in that case.
You
Okay,
can continue, sir.
yeah. Okay, so yeah, so I was just mentioning about the concept of metering, and when we basically go for universal metering, where you have to meter all consumers, one valuable asset that we get is the data of consumption from user side, which can be used for like further analysis, and it's a valuable data which can be used for the information and which can further be used for decision making. But just for the sake of that user data, we are we have huge investment to make. We have to household each and every meter. So that probably then it is not justified. However, if we are charging consumers based on the consumption, if we have a plan to charge the consumer based on the consumption, like not if you are not metering consumers, all you can charge the consumers at a flat rate. So when you are charging, let's say 200 or 300 rupees a month to the consumers at a flat rate, then there is, of course, no control on the water uses. So a household can consume, let's say, 50 kiloliter water a month, 40 kiloliter water a month, or whatever. But if we meter the consumers with the idea of charging the consumers based on consumption based tariffs, then it makes much more sense, because then the household which is consuming 50 kiloliter will not end up paying just 300. They will be probably paying 1,000 rupees a water bill. So the cost for putting that meter will be justified in that case. Okay, so the utility eventually has to see that because for purpose of metering there is an investment required. Now utility has to see that what way that investment is going to give us return, or is going to be profitable for us. So metering can help in the getting data. Metering can help in the like reducing water wastage, identifying wastages if there are any, and giving a signal to the consumers for saving water. And but all this is not justified if you are not charging on a consumption basis. So if you are charging on a consumption basis, if you have a plan to charge on a consumption basis, metering in long term is definitely going to be beneficial. Okay, there is no way like you can avoid meters if you are planning to charge on a consumption basis, or if you have any such idea of making your utility sustainable, because then you will have to charge on consumption basis. Okay, the other approach, like for data purpose, you can go for optimal metering, where basically if you are not charging, like let's say if government has decided that no, we are not going to charge for water. Okay, like in West Bengal, majority of the areas water is free. In some other states also there is no charges for water. Okay, or many places there is just a symbolic flat charge. So even if in Rajasthan, quite a few cities the meter has been installed, but still the billing is not as per meter. Billing is still flat basis. Okay, so if we are into that regime that we are not going to bill the consumers based on their consumption, then there is a no point in investing so much money in installing meters. Then we must go for optimal metering, like placing meters at a strategic location so that we can still get the data about the consumption. Okay, we can still get the may not be household consumption, but let's say a total water going into a particular society. Okay, so how many households are there in that society? We'll not get an individual household consumption, but we can get a consumption from a society or from a locality. So that sort of optimal metering can be done in order to get the data, which can then further help in decision making and other thing. And we can avoid universal metering if we are not going to charge. However, ideally, the supply system has to aim for sustainability, even the financial sustainability, and for that purpose, metering is required. Universal metering is required. Okay, so that can be certainly justified in long term. The other part was, what is the best model to price water? Well, the most popular model worldwide, of course, means there are several models which we discussed: the flat rate, uniform rate, or increasing block tariff, okay, or seasonal tariffs. So flat rate is, of course, should be done away with, because that is applicable only when we have no meter. So there is no option available. We have no option but to go for flat rate. Other than that, okay, the uniform tariff models are also not good for water supply uh, systems, okay, because they do not send any signal of consuming water, and then they basically rate all the consumption, whether it's in a basic essential lifeline consumption or a luxury consumption at the same rate. Okay, so the best model which is being adopted worldwide also, which people are promoting as well, are the increasing block tariff. Okay, IBT models, where we have different slabs. So we can look at those slab wise, like we have a basic lifeline slab for basic consumption, which is at subsidized or low rate, and then we have a medium range of consumption at least, where basically our uh, further needs are fulfilled, and then at towards the end we have like for those who are leading to a luxurious life, they should not get a subsidy or other things. So for them we can have a high rate, and maybe further higher consumption is there, we can put further higher rate and with some sort of penalty as well. Okay, so that is the popular model which is being adopted worldwide. Okay, and which is kind of good also, in a sense. It seemed like that in the power sector. So water sector also, in India also, many of the cities has adopted IBT model, where the consumer metering has been done. Okay, so the increasing block tariff models are best one. But if you do not have meter, then also at least you should charge some flat rate at least, because otherwise giving water for free is absolutely like not an encouraging thing to have. Okay, so there are few other attempts, like there is a allocation based this thing, or seasonal models are also good in that sense, particularly where you have frequent droughts and those things. So you can have much higher rate in the drought season in order to give very strong signal for reducing the water consumption when there is a crisis period. Okay, so for places with frequent drought, of course, the seasonal model can also be adopted, or even the IBT model itself. You can add further in, like you can revise the rates in the peak seasons. Okay, so that opportunity or that option is also there. The as I was just mentioning, the allocation based model has also been studied, although have never been implemented, where the allocation, like in IBT or other places, the base tariff allocated is fixed. Okay, you have 10 kiloliter, let's say, base limit. So 10 kiloliter at a rate of 8 or a rate of 10 or rate of 5 or 4, whatever is the rate per kiloliter. But you have a base, like the basic minimum, this thing is fixed. But this basic 8 or 10 kiloliter remains same for all consumers. Okay, so then there is an like because you may have a family with one connection where there are 10 people, you may have a family with water connection and there are just 2 people. So there the 2 people have luxury to use 8 or 10 kiloliter water at a nominal rate or low rate or subsidized rate, whereas there the 10 people have just 10 kiloliter of 8 or 8 kiloliter of water to be used as a normal or subsidized rate. So then in order to make it more equitable, the studies has been conducted to kind of go for a like allocation based model, where each household, depending on the size of house and other thing, is allotted different like water, different amount of water in that base or subsidized means subsidized rate. Okay, so the quantity in the base rate is different for different households depending on the family size or sometime even income size and other things. So various other criterias can be clubbed in order to get an idea of this. So that sort of like further studies are being done, but these has not been implemented so far. Okay. So that's all. I think I don't see any more questions here. Okay, so if there are any more questions, please post it in the chat box, or else we can close the session now. All right, so looks like no more questions. So in any case, I thank you all. I thank you all for joining this session. As you are aware that exams has been postponed due to the uh, pandemic uh, related restrictions, and but it will be like conducted as the situation normalize. So I wish you all the very best for your exams. Thank you for attending the lectures, course lectures. Thank you for giving the company in the live sessions. And I hope that the interactions, the lectures, the deliberations has been useful to you. Okay. And I look forward to like meeting you again or in some other course or another time. Okay. And I hope that like you would have got something, some knowledge or some information from this course, and this would have been helpful to you. So thank you for joining. Thank you for your company over last 3 months or so, attending lectures, solving assignments and other thing. And those who are for exams, I wish you all very best for your exams. In case of any further questions or queries, please feel free to post in the forum. We'll adequately address all your concerns there. So thank you for joining. Have a good day.